Thank you, Riley, and welcome everyone to this month's Connect with BMC Helix ITSM and Remedy webinar. For today's presentation, any questions that you have during the presentation, you can ask via the Q&A pod. Our panelists will be able to answer those during the presentation. And today's presentation and Q&A will be posted a week from today's live air date on the communities area. And at this time, our Smart Reporting Performance Best Practices talk, I will turn over to Bharath and Daniel to take us through this content. Go ahead, Bharath.
Thank you, Greg. Hello, everyone, and welcome to the Remedy Smart Reporting Best Practices webinar. So before getting into the topics, I would like to introduce myself. I'm Bharath Kumar, working as a Smart Reporting SME. And I have my colleague Daniel Marrujo with me over the call. I have been working with BMC software for the last 5 years and on the smart reporting product line for the last 3.5 years. We also have our smart reporting team over the WebEx to answer your questions, while I and Daniel will be presenting the content. So in today's webinar, we will discuss about some key aspects of Remedy Smart Reporting. We'll get started with the overview about how this session helps the smart reporting customers to analyze and size their environment. We will talk about setting up the smart reporting environment in a cluster and deploying a dedicated AR server where data is fetched from a replicated database. We will also look into some performance optimization techniques which helps to tune the application, and some common configurations, some best practices within the application to avoid issues with user sync and some DST related issues. At the end, we will also talk about the findability of smart reporting knowledge articles using appropriate keywords in the BMC support search. And finally, we will have a Q&A session where we will respond back to your questions. Please note that we are referring to the latest smart reporting version, which is 1902, throughout this webinar session. So to just give you an overview, by the end of this webinar session, you should be able to have a good understanding of the deployment model of smart reporting, the sizing and architecture of both the standalone and cluster environments. We will provide you a good understanding of the cluster mechanism, how the session replication works in smart reporting, and what are the configurations that are required for load balancer to integrate with smart reporting. This session will also help you understand how to set up a dedicated AR server for smart reporting, where data is fetched from the replicated DB, which helps improving the report performance, avoiding any impact on the live database. This session will also help you troubleshooting the performance issues both at the application end and at the DB end. And finally, we will present a way to configure the application to avoid issues with DST with both the reports and at the broadcast level. And at the end, we will talk about some common core logs of smart reporting, basically what log has what information, which helps to identify the cause of an issue. So I will talk about the clustering part now. As you know, you can have 2 or more smart reporting nodes installed in a cluster, sharing a common repository database. So the common database, which is nothing but the DB, which stores the metadata information like your the report definitions and the view definitions or the user data or any configuration that is configured on the application level. So smart reporting nodes can be configured in a cluster to allow high availability and proper load balancing. So what are the best practices to build a cluster environment? In the primary node installation or the first node installation, you create a blank database or a blank schema prior to the installation and provide the database details during the installation, which is just a straightforward standalone installation. Now, coming to the secondary node installation, the same database details can be provided during the installation, but ideally, the installer expects the database to be clean and blank. But once the installer detects the smart reporting related objects, like the tables, it will not make any changes to the database objects. I mean to say, the installer does not look to recreate the database objects again, since they are already created during the primary node installation. So in case of the secondary server installation, it will just write the smart reporting related binaries in the on the file system, thereby finishing the secondary node installation. Now let's take a different scenario. Let's say you already have a live standalone smart reporting instance running, and you want to add an additional node as a cluster. So in this case, BMC do not recommend you to install the secondary node with the existing repository database. This is just as a precaution to avoid any overwriting in any of the existing smart reporting related tables. In this case, customers can create a dummy database or a blank database for the secondary server installation and proceed with the installation. So post the installation, once the secondary node is installed, it can be pointed back to the smart reporting existing repository database. So now you have two smart reporting nodes installed. These two nodes are sharing the same database, but they are not part of the cluster now. So the cluster mechanism it's a standard Tomcat clustering, which helps in the high availability and load balancing. Now next part is the clustering of both the primary and the secondary nodes. So what are the different types of cluster modes that are available? So we have two modes of clustering. One is a dynamic mode, which uses the multicast broadcast to detect the available nodes in a cluster. And then we have a repository cluster mode, which uses the TCP mechanism to detect the available smart reporting nodes within the cluster. In addition, we also have two different clustering levels. Basically, there are two different components of the cluster environment. Application level messaging, which is required for the cluster to operate correctly. And then we have a container level session replication, which is nothing but a high availability mode. In addition to this, we have another configuration called background tasks. So this is an additional configuration to enable or disable the broadcast reports. Not only broadcast reports, but there are other background tasks like refreshing of the access filters or refresh of your cached filters. These all come under the background tasks. For example, let's say you have two smart reporting nodes without any trusted configuration, and user is accessing them using the load balancer. Now, user has configured a broadcast report to run on a daily basis. In this case, since there isn't any configuration defined, the report will be sent twice from each node. Thereby, the user will receive the report multiple times. So to avoid sending of duplicate reports, it is required to configure the background task to run on any specific node. First, I will talk about the dynamic cluster mode. So as I said, the dynamic clustering uses the multicast messaging. The multicast messages, the multicast libraries are called the J groups. So multicast is it's a purely a network concept, which is a one-to-many or a group communication within the available nodes, where individual smart reporting nodes send heartbeat to each other and they identify themselves as a cluster. Thereby, they will form a cluster. So multicast library totally relies on the UDP protocol. So to enable the dynamic cluster mode, we will define the below cluster classes in the web.xml file of the root folder of the smart reporting. So the cluster type, you can see it is dynamic. As I said, dynamic uses multicast messaging and will automatically find the remaining nodes in the cluster. The multicast messaging allows finding of the available nodes in a cluster, and it allows the available smart reporting nodes to talk to each other. Similarly, we also have an additional classes, serialized web service sessions, which is used to serialize the sessions or the tokens to the database, and so that the same token can be accessed from any other node. Similarly, we have another class called checksum rows, encryption session ID, and encryption session data. So these are all a kind of security option to encrypt the serialized or the web service sessions and store it in the database. We also have another configuration, another class called auto task delegation. So setting this to true, when it is enabled, the cluster will automatically assign a node to perform the background task. As I said, there are broadcast reports or refresh of access filters or cache filters come under the background task. So when this is turned on, when the auto task delegation is set to true, you don't have to manually configure a node to run any background task. The mechanism will turn off the system tasks on a node at startup if another node is already delegated to perform this task. So this is about the dynamic cluster mode. Similarly, we will need to define the multicast libraries in the Tomcat Java options. So the multicast address and the multicast port needs to be defined for dynamic cluster mode. Here the address attribute you see is it's a multicast address. Basically, it has a range of 228.0.0 from 228.0.0 to 228.0.5, and it will use the multicast standard port. So these together, the multicast address and the port together form a cluster separation. Let's say you want to have a QA cluster and a production cluster. So in this case, the easiest way is to have both QA and production on separate multicast address and port number combinations. So that will allow you to have QA and production in separate clusters. So as I said, multicast helps in discovering the nodes, and it allows the nodes to talk to each other, thereby forming a cluster. Next, I will talk about the next cluster method, which is the repository mode. So repository mode uses the TCP mechanism, for the available nodes. In this case, we don't have to define the multicast libraries in the Tomcat. The multicast libraries only comes into picture when we are using the dynamic mode. And for the repository mode, they use the TCP mechanism to detect the available nodes which are the part of the cluster. So this can be used, the repository cluster type can be used where the UD multicast packets do not work. And the remaining configuration like serialized web service session, checksum rows, and encryption sessions, auto task delegation, which remains the same here. In addition to defining the cluster management, we will need to disable the background system task just by commenting out the system task class, which can be seen here. So all the configuration related to the cluster management, they all go to the same the web.xml file, which is a core file located at the root directory. So this will disable the all the tasks visible in the task schedule menu, which includes the group flattening or the LDAP synchronization, which we do not use for smart reporting. In addition, as I said, we will configure the background task. So this configuration is only required in case we are not defining the auto task delegation to true. So having auto task delegation to true, that will automatically assign the nodes to perform the background activities. If we do not add the auto task delegation to true, then you can manually assign the tasks to run the background task on any specific node. So we have a very good documentation about where to add these configurations in exactly which class you need to add this. That we have this at the end of these slides. So now we have completed the cluster management part. Next part is the container level session replication, which is nothing but a high availability mode. So container level session replication allows smart reporting to be deployed on in a safe environment where in case of a node failure, the current logged in user can continue their session on the available nodes. So session replication writes the session, the user session to the available nodes. It creates a duplicate of the existing session to the remaining nodes of the cluster. Thereby, if the active node where the user is logged in goes down, then the same session will be continued on the secondary node. So to enable the session replication, it is required to add the distributable tag in the web.xml file just below the web app line. In addition to this, we will also define the session replication part. Setting the session replication property to true. This will make sure that the user session is not killed when in case of failover. So this session replication part will go into the cluster management class, which we have seen in the earlier slides. In addition to this, we will also add an additional XML entity in within the host XML block of the server.xml file. This is about setting up the session replication or a high availability of the smart reporting nodes. Now, next is you have the load balancer in picture, where under that you have multiple smart reporting nodes. So for load balancer, we have we recommend a specific configuration, especially for the smart reporting, which is the sticky bit session or the session persistence on the smart reporting load balancer itself. So sticky bit session is a method which is used by the load balancer to achieve the server affinity. Using sticky sessions, it can help improve the user experience, and it can improve the Tomcat performance, exchanging the data. It minimizes the data exchange and the RAM cache utilization. In case you have two smart reporting nodes with a load balancer without any cluster configuration, then you might face issues accessing the smart reporting URL from mid-tier or smart IT. It may land up to SIADMIN login page, or sometimes it may take you to it will throw you the error like session timeout or session expired. So having this configuration in place, the cluster configuration and the sticky bit session on the load balancer, this will make sure that your smart reporting works very accurately with the load balancer. This is all about cluster configuration and high availability. Next, I will talk about setting up a dedicated AR server for smart reporting. So first of all, why do you need a dedicated AR server? Let's say in an organization you have 100 active users in ITSM, and you have about 10 users in smart reporting who are running the reports. So the calls or the queries that are coming from both the ITSM and from smart reporting, they are hitting your live database. So thereby impacting your live database. So in this case, you might see some slowness in the database itself, or you might see slowness within the ITSM console, or you may also see slowness with the reports runtime in the Smart Reporting console. Additionally, you may also see some long-running queries or some idle sessions hanging in your live database. So in order to avoid such challenges, our recommendation, especially for the production environments, is to have a replicated database created and have a dedicated AR server for Smart Reporting. So in this case, the queries which are fired from the Smart Reporting will be going through the dedicated AR and are fired on the replicated database, thereby minimizing or avoiding any impact on your live database. So the replicated database can be in read-only mode since it is only used for the select queries from Smart Reporting application. So this Smart Reporting AR will be only used for Smart Reporting queries and is not part of the any admin operations. Though it is part of the actual server group, but it will not handle any admin operations. So how do I install the dedicated AR server? So the installation is just a straightforward installation. During the AR installation, you can install it pointing to your the live server group database. And once it is installed, you will need to disable the admin operations on it since it is not going to handle any admin operations. Since the AR is installed on the production DB, it has entries created on the operational ranking form. As I said, the dedicated AR is not involved in any admin activities. It is necessary to turn the ranking to null or any blank value in the operational ranking form, which means that it does not take part in any admin activities. In addition to this, we will also need to delete the references of the Smart Reporting AR server from the below mentioned tables, which are server group application, board, config, FTS license, resources, and user license. In addition to this, we will also need to explicitly disable the admin activities. As I said, we will need to add the disable alerts, disable archives, disable escalations, disable the full text mode, disable the full text, disable indexing and searching. These parameters we will need to explicitly add in the ar.config file. So once the dedicated AR is set up, once the admin operations are disabled on the dedicated AR server, the AR can be pointed to the replicated database by just updating the database details in the ar.config file. And once we have the AR server ready, the dedicated AR server ready, we can configure the Smart Reporting data source details. We just need to update the database host name, changing it from the admin AR server or the server group AR server to the dedicated AR server. This can be done by logging to the Smart Reporting with the reporting administrator and going to the data source details. We will just need to update the AR server host name. In case of a new onboarded system, the onboarding has to be performed with the server group AR or the admin AR server. So basically, onboarding creates the data source connection from Smart Reporting to the AR server. And once the onboarding is completed, post that, if you want to change the data source from admin AR to the dedicated AR, just update the host name of the AR server from the data source configuration. As I said, the dedicated AR is not the user-facing AR. It is an idle AR just to handle the Smart Reporting request. To make the best out of it, our recommendation is to have AR server and Smart Reporting installed on 2 separate servers. That's all I have for today. I will pass it over to Daniel. He will continue with the performance optimization techniques. Thank you.
Thank you, Bharath. Let me introduce myself first. My name is Daniel Marrujo, and I've been working for Smart Reporting for a couple of years. And I'm going to present you the topic about performance and best practices to take the better out of your Smart Reporting application. So let's start with it. The first that we need to know in performance is where is your issue in performance. There are three possible sources that may cause a slow performance on your system. The first one is the Tomcat, and you can confirm it if you have a slowness when you're moving between the menus. This means when you're moving from Explore to Dashboards or to Admin Console, and you see that that's taking too long, you may have a Tomcat issue. I'm going to go over all of them one by one. I just want you to have a big overall of what are the possible causes of performance issues. So the second issue that you can have on performance is related to the performance of the database. And I'm not talking about the AR database. It's the metadata database that is for smart reporting. You can notice this on high waiting time when you click on browse, and it takes lots of time to load the list of reports that you have in there, or when you hit create a new broadcast and it's still spinning over and over and like forever, and that's also related to the database performance. Also, you can notice it with high log performance to go to the schedule management, all related to load tables or reports or report definitions are on the database performance. And the last part is a slow performance when loading your information. This is when you already open your report and you click on go and you go to the AR database to fetch the data. This is all related to the AR and the AR database itself, because the smart reporting can be working good, but if you have a slow performance on your AR, you will have issues fetching your incident data or all kind of data that you're trying to fetch. So with these three in mind, let's go over the first one. So now that we know the three sources, we also need to know if your system is capable to get with the load you're managing in there. We have a table in here where you can know if you have the right architecture. So for a small architecture, this is the recommendations that we do to you. You can have a 4-core CPU and you need a 12 gigabytes RAM on that server just dedicated to the smart reporting. Also, we have the medium one that runs up to 16 gigabytes, and for the large one, we need a 32 gigabyte space just dedicated for Tomcat. Also, this is a very important part, the concurrent users, and maybe conflicting, or you may confuse this one. Concurrent users means the regular users that get into smart reporting. You may have 1,000 users in your AR remedy system, but only 50 of them actually go to smart reporting and run queries and run reports. So depending of the amount of users that are actually using the platform or use it at the same time, you will need one of these architectures. All these acceptance count, max threads, connection timeout, and all these parameters are parameters that you need to configure in the server.xml. This is just to get the better of the tool, because the default is just to consume 2 gigabytes of RAM. So you need to ramp up these settings to consume the adequate to get the better of your Tomcat and your smart reporting. I'll get deeper into this in the next slide. So this is what I was talking about. These are the default values. Is the initial and the maximum memory pool that you need to ramp up depending on your architecture. So take a good look to these parameters that you need to ramp up. So the recommendations that we always do, specifically for production environments, is to always use a server dedicated for smart reporting. And if you, for example, if you have a small requirement based on my last slide, the Tomcat must consume the half of your total RAM. This means, based on the previous slide, if you need 12 gigabytes of RAM just for the Tomcat, you will need to have the double of RAM. You don't want to get the operating system to be consume all the RAM, or your server will be stuck up. This is the second point in here. To use always the half of your total RAM in the system. And the configuration that I was talking about is on the server XML, and you can see it in here. For the compressible memory type, this is already on all 1902 fresh installs. So you don't need to worry that much about this, but take a look and see if this match with all the parameters that are on this table. At the end of the presentation, there's a link with all the recommendations on sizing that you will need to take care about on the server.xml file. This is just an example of how it looks like. And if something is missing on the server.xml, you just need to add it according to the table that we have in here. Active count, max threads, connection timeout. It's all on these lines. Max threads, min pairs, max HTTP header sites. So about the compressive MIME type, this helps or will help a lot to have this configuration, because all the calls that the system is doing will get compressed. So the load time will be considerably ramped up by this configuration. So you will need to have all these types to make all the calls get compressed, so your performance will be a lot better with this configuration on the server.xml file. Also, for the Tomcat, for the garbage collector for Tomcat A or higher, you'll need to use these configurations. The garbage collector is a Tomcat snap that you need to put in there. So with this configuration, all the garbage in the system will be resumed, so you won't have stocks in your system. So this is all about the Tomcat snaps. There's another very good configuration tip that we can do in here. We noticed that the default to get into smart reporting is to get into dashboards. So when a user gets into the tool, it will be defaulted to dashboards. This can have a very large amount of load depending on how many dashboards you have in the system. So what we recommend is to set all the users to rows using this query, or any individual user in the properties, they can set this up. In the entry page, the default is dashboard, as I said, but you can change it to browse or to timeline. This will reduce the amount of time it gets to the system to do the first load when you get into smart reporting. Okay, database tune up. What we recommend is to clean up the event tables. Event tables is nothing more but statistical data that contains all the activities that the users do on the tool. If a user creates a new report, it will be captured in here. If a user erases a report, it will also be captured in here. This is just statistical data, and there's no risk on deleting this data. In previous cases, we see that truncating these two tables, that is the event table and the event archive, it really increase the performance of the tool. There's a further configuration to prevent these events to go too big. We need to run these two queries. So when you get to 30 days, all the data in an event will get to event archive. And passing 60 days, all the data in event archive will be deleted. So running these two queries will guarantee you won't have a performance issues on the database related to the event tables. You can also play with these numbers. We suggest 30 and 60, but you can change this. If you have lots of transactions in your system, you can get this down to 15 and 30. You can play with these two numbers according to the number of users and the workload that you get in your system. So to do this or to run these queries, just make sure to change the IP org. We put a one in here just as an example, but you need to get the actually IP org of your organization. So for this, you'll need to run this query that will tell you what are the actual organization that you onboarded into your system, and you will see that IP org in name in there. So just run this query first to know what's your IP org, and just replace that IP org in these two values. So with this configuration and with the truncate of the event tables, you'll get rid of most of the performance issues on the database. There's one more configuration I'll take over in the next slide. So the last step for database configuration is to clear the document table, but this cannot be truncated just right away. You'll need to run a specific query that is specified in the documentation at the end of this presentation. The document table stores actual data or historical data of your reports. The only way to get historical data is when you publish a report, you will need to set the refresh settings to manually or periodically. By doing this, you will create historical copies of all your data, and all of this is stored on your Smart Reporting database. You know, this can get really, really big if you have this enabled and you're running constantly your reports to have historical data. So to prevent this, all these configurations is over the folder settings. If you right-click in a folder, you'll get this configuration. So in this, it says keep historical data. You'll need to change this to just keep the last one to avoid getting any kind of data into your Smart Reporting database. That is what we recommend. And only if you need historical data, we recommend to change this. But if you do not require to have historical, please keep it to keep only live. And you can also play with these values to have the max size of the reports stored in the database, how many historical versions you should have when they will get deleted. The default is 1,000, 24 max versions, and to store it only for 2 weeks. So run the query and change the folder settings to tune up your database performance. Those are the only recommendations that we can do, and this will really increase the performance on your database. For the server tune-up, the best recommendation already was done by Bharath, that is doing the replicated database. This will avoid some issues and timeouts because all the workload will go to the replicated database and not to the live AR database. The only other recommendation that we can do is to disable the new errorless implementation. Again, at the end of the presentation, there's a very good article with a step-by-step about how to change to the new, to disable the new errorless implementation. Errorless stands for row level security, and it is the way the query goes to its own AR database. So there was a change in there about how the groups are managed and how the query goes directly to the AR database. So if you had some issues or you see a large amount of times to load the data from the AR database or timeouts, you can try disable the new RLS implementation. Also, if you don't care that much about how much time is taking to retrieve the data, we recommend just to increase the AR epi timeouts. You can add this in the Tomcat configuration, and there are three factors in here. They are separated by columns, and the first one stands for the small queries. The second one is for the medium queries, and the last one is for the large queries. So we recommend to ramp up all of them. All of them are in seconds. And it is the wait time that the connection will be open to retrieve the data. It's more reporting to retrieve the data from the AR server. So you can increase these timeouts if you know that the report may take lots of time to retrieve the data. And just a heads up that we are introducing a new RLS implementation, so the load or the managing of the role level security will be better on our new coming version. Okay, so this is all about performance, and I would like to talk about other configurations that we see customers are struggling with. One of it is the DST, that stands for Daylight Save Time configuration. There are some issues that when the countries change to Daylight Save Time, the reports do not change, or smart reporting do not change. This is because there are three factors. The first one is that in the individual user configuration, this time zone is meant to GMT. If this is to GMT, any daylight configuration will take place. Second one is the same. You must have a time zone in here, not GMT, and you must have enabled this on your server. If you have a cluster, all of them needs to have this configuration. The last time is that in the broadcast, you have a time zone specified. Also, do not use GMT or this won't work. So three factors: your profile, the server, and the broadcast. These are the three configurations that you need to take about if you want your DST to work. So with that said, let me go to the next slide. These are some user sync best practices. Always run the user sync escalation on your admin AR server. Check the smart reporting server info if all the parameters are okay. This is a screenshot for that smart reporting server info form. This means the smart reporting host, make sure your port is okay, make sure the SI admin and the password are correct, and if the org name is also correct. Most of the issues of user sync are getting solved on this escalation. Also, if you're using SSL, make sure that the AR Java Truster has the certificates of smart reporting, because if not, there will be some issues with the handshake of the SSL. We see many cases like this where the AR cannot communicate with smart reporting, and the issue was that the certificate was not in place. So make sure this is all in place, and the AR and smart reporting are able to connect to each other. And the last recommendation or a heads up is that if you delete a user from the ARCTM people or the user form, the user will be deleted from smart reporting. The only consideration is that if the user have private reports, the user won't be eliminated from Smart Reporting. It will get deleted manually, so the ownership of all that private reports will get transferred to a new person, and the private reports won't get orphaned. This is a new implementation starting from 1808. So just a heads up that this is on place, that the private reports won't get orphaned anymore. Talking about logs, these are the principal logs that we have in the system, starting from the properties. This is not really a log. This is where you configure the log level, and it's in the same folder of the web XML that Bharath shared before. In here, you can change the debug level to debug to have better logs to get the debug easier. The next one is the smart reporting.log. This is the principal log where all the operations of smart reporting goes. So if you run a report, any broadcast that is running or any connection will be logged in this log. JDBC log is a very, very good log. It contains all the connections that smart reporting do to its own database. This log must be clean always. It should not have any kind of issues because it can cause corruption in the database. So if you see that the system is not coming up or there's any issue with the service, I recommend you to go to this log. This log will say if a smart reporting service was able to connect to its own metadata database. The source log is very similar to the JDBC, but this have all the connections that smart reporting do to the source. Source in this time is always the AR server. So this can have errors. It's not that critical, but if you see issues that you cannot retrieve data in smart reporting or you are not able to connect to the AR, I recommend you to go to this log to see if there are any issues or smart reporting is struggling to connect to the AR server. Email.log. Email.log contains all the information related to broadcast. Any email that is sent from smart reporting is captured in here. It contains when it runs, who is the sender and who is receiving that email. So if you are debugging broadcast, I recommend you to go to this email log to ensure if there's an issue running the report or if there's an issue with your SMTP server. And the last one is the SR.logs. All the logs that start with SR contains all the errors that are on the admin console. If you are onboarding and have issues or importing content and you have issues, all those issues will be captured in these logs. Findability. So these are just some good practices to find our articles and our documentation. We always recommend to go to our Support Central to look for information and also our product pages to get the official documentation. In all your searches, please include the error message. This will help you to get the best article or the documentation available. In case you're using Google, always start your search with BMC Smart Reporting or the name of your product. This is the way we search sometimes, and it will take you directly to the community articles that are in there. If you're looking for configuration steps, we recommend to go here and search directly on the documentation. And always in all your searches, include the version that you're talking about or want to get information. This is all from my side. This is the reference that I talked before. So I'll hand up to Greg to wrap up this webinar.
We do have one question in the Q&A area. It is when to use dynamic clustering and when repository clustering for smart reporting setup. Bharath or Daniel, would you answer that, please?
Yes, Greg. So customers can go for repository cluster when the multicast libraries do not work in the environment. And when they have multicast libraries working, then they can go for the dynamic clustering.
Okay, we'll go into the wrap-up. I just wanted to remind everybody about our self-help in contacting BMC. The YouTube channel is where all these webinar recordings are posted, along with a lot of how-to videos are provided within there. The Connect webinar schedule is at this community's link, as well as the Hot Off the Press newsletter with a lot of trending information is available within communities as well. You are able to contact technical support via the web, phone, and email, as well as these social channels. At this time, this will conclude our presentation for this month, and I wanted to thank everybody for joining us, as well as the presenters and panelists. Thank you.